Again, one more VT graph is given. A body is moving in a straight line as shown in VT graph. The displacement and distance traveled by a body in 8 seconds. And average velocity and average speed in 8 seconds. So from VT graph only we have to talk about again average velocity and average speed. See, we know displacement. Integration dx is equal to integration v of t dt from t1 to t2 gives you, this is x2 minus x1, that is the displacement, is equal to area between VT graph and time axis between those two time limits. That is the displacement. But this area is positive, this area will be negative, this area will be positive. As far as displacement is concerned, positive area plus half minus negative area plus this positive area, that is the displacement. As far as the distance is concerned, it won't be negative, that's why this area plus this area plus this area, that gives you distance. So displacement is equal to this area. This area means 2 units is length, breadth is 4. 2 into 4 is 8 plus this is a negative, so 2 units, again 2 units, 4 minus 4 plus here 4 to 8, so 8 minus 4 is 4. 4, this is 2. 4 into 8, 4 into 2, that is 8. So 16 minus 4 is 12 meters is the displacement. Now distance travelled, that means path length. Distance travelled is equal to 8 plus this negative also we take positive plus because it won't be negative, and 8. What do you get? 20 meters. That means if you go for actual physical situation, initially from where it is starting it did not give. From this information we don't have any, from this graph we don't have any information regarding that. Let me take it starts from here, and it starts with 4 meter per second and it is positive and constant. So constant velocity, acceleration is 0, it moves like this. Next after that for 2 seconds, after that 2 to 4 seconds with minus 2 meter per second, means direction of motion changes 2 meter per second, 2 to 4 seconds, and again from 4 to 8 seconds with 2 meter per second it is along positive x-axis, positive again like this. So we have to go for displacement. Displacement means this one minus this plus this, means you will be getting this distance, that is the displacement actually. And path length means this one plus this one plus this one, this is the path length, that's why I have taken it as positive. And displacement means we have to subtract it. So this distance minus this one plus this one, it gives you displacement. Now we have to go for average velocity. Average velocity means displacement by time duration. So displacement is equal to 12 meters, duration of time is 8 seconds, that means in 8 seconds only we have calculated area. So what you are going to get? 3 by 4, 3 by 2, that is 1.5 meter per second. Now average speed. Average speed is equal to path length. Path length is 20 by 8, 5 by 2, that is equal to 2.5 meter per second. Here direction of motion has been changed, that's why displacement magnitude is less than distance magnitude or path length magnitude. Average velocity magnitude is less than average speed magnitude. So from VT graph only we are going to calculate average velocity and average speed. Suppose if we ask about instantaneous velocity from VT graph, direct we can read the value. At 1 second, what is instantaneous value? 4. At 2 seconds, 4. At 3 seconds, minus 2. At 4 seconds, it is plus 2. At 8 seconds, again plus 2. At 5 seconds, again plus 2. So like this we can read instantaneous values directly from graph. But from VT graph only we are going to calculate average velocity and average speed. That is the main purpose of discussing this diagram, this problem. And already we have solved one more problem. There VT graph is given. From that we have calculated displacement and distance. But we did not discuss this average velocity and average speed. Now I am covering that part.